Let's jump right into this explainer. We're chasing the absolute holy grail of homemade organic pickles today, the perfect crunch. If you've ever tried fermenting at home and ended up with a sad, mushy disappointment, well, you're definitely in the right place. We're going to break down the exact science of the 3.5% saline protocol.
So there's actually a huge distinction between what most people think pickling is and true aquatic lactofermentation. Look, if you're just after that sharp, one-note bite of a fast food pickle, you want quick pickling. Basically a hot vinegar, water, and sugar pour over. But for that complex, round, deeply earthy sourness, you've got to abandon vinegar entirely. True organic pickles actually produce their own lactic acid through fermentation.
Here's how we get there. First, the enemies of crunch. Second, the 3.5% saline matrix. Third, aromatic architecture. Fourth, anaerobic submersion. And finally, troubleshooting the ferment.
Section 1. The enemies of crunch. Protecting structural integrity. Before we even touch the protocol, we gotta ask, what actually destroys a pickle's crunch during fermentation? Like, why do so many homemade batches just fail? The data points to two main culprits: warm cell walls and polygalactoronase enzymes. If we don't mitigate these right out of the gate, getting that crunch is practically impossible.
First off, standard English or slicing cucumbers, completely out. They hold way too much water and will absolutely turn to mush on you. You've got to use Kirby cucumbers. Second, to fight off those warm cell walls, you need to execute an ice bath intervention. Literally submerge your cucumbers in ice water for 1 full hour before processing. It physically contracts the cellular structure and locks in that firmness.
Now, the real secret here comes down to a tiny measurement. Exactly 1/16 of an inch. It sounds almost unbelievably precise, right? But that tiny sliver is literally the difference between a triumphant crunch and total ruin for your entire batch. This is what's called the blossom amputation. You need to slice exactly 1/16 of an inch from the blossom end of the cucumber. You know, that pale dotted end opposite the stem? Why? Because that specific tip is harboring those polygalactoronase enzymes we talked about. If you leave it attached, it'll systematically digest the pectin in your jar and turn all your hard work to total mush. It's a critical structural intervention.
Moving on to Section 2, the 3.5% saline matrix, synthesizing the environment.
Unlike cabbage, which you can massage to release enough water to brine itself, think sauerkraut, cucumbers just don't do that. We have to build their living environment from scratch. And this matrix is incredibly specific. You need exactly 1,000 grams, so 1 liter, of cold, filtered water. Do not heat it, or you'll cook your cucumbers and kill the crunch. Then you whisk in exactly 35 grams of fine sea salt or kosher salt. And this is crucial. The salt has to have absolutely 0 iodine and 0 anti-caking agents. Now about that filtered water, it is non-negotiable. Standard tap water is treated with chlorine, which is fine for drinking, but that chlorine will literally assassinate the good lactobacillus bacteria we're trying to cultivate. No bacteria means no lactic acid, and no lactic acid means, well, your ferment just won't happen. It's a real light bulb moment when you realize why so many tap water ferments fail.
Section 3, aromatic architecture, building flavor and armor. The foundation of your jar is organized into modules. You got your standard base, smashed garlic to release allicin, fresh dill, mustard seeds, and black peppercorns. Then you have the optional spicy isotope module. Toss in halved jalapenos for medium heat, or a needle-pricked habanero if you want extreme heat. But the absolute most intriguing element here, the tannin binder.
This is one of the coolest takeaways. You drop in 2 organic bay leaves or a pinch of loose organic black tea to get those tannins. And they aren't just for flavor, they act as literal cellular armor. The tannins chemically bind to the pectin in the cucumber, reinforcing those cell walls against bacterial softening while it ferments. It's basically a microscopic shield for your crunch.
Section 4, anaerobic submersion, the execution phase.
All right, so there are 3 critical physical steps to execute here. Step 1, the pack. Wedge those cucumbers in tightly over your aromatics so they physically cannot float. Step 2, the pour. Submerge them completely in your cold 3.5% brine, but, and this is key, leave exactly 1 inch of headspace at the top of the jar. Finally, step 3, the lock. Apply a glass fermentation weight to force every seed and pepper strictly below the liquid line. Oxygen exposure breeds mold, so this strict anaerobic lock keeps everything totally safe.
Now the waiting game begins at room temp. Between days 1 and 3, the jar is going to get cloudy.
Don't panic. It's not spoiling. That's just a sign of really healthy, active bacterial reproduction. Around days 4 through 6, you hit the half-sour stage, fresh and a little tangy. Then, by day 7 to 14, the lactic acid fully permeates and you're at the full sour stage. Once it hits your ideal flavor, just move the jar to the fridge to halt the fermentation and lock it in.
Section 5. Troubleshooting the format. Handling the panics.
Okay, so this is an incredibly common panic. You do everything perfectly, the flavor is phenomenal, you bite into a beautifully sour pickle, and you find out it's completely hollow inside. What on earth did you do wrong?
Well, good news. You didn't do anything wrong. A hollow pickle is actually an agricultural failure, not a fermentation mistake. It happens way before the cucumber reaches your kitchen, usually because it grew too fast on the vine or it just sat around too long after picking. The fix for next time? Source the smallest, firmest organic cucumbers you can and get them into your brine within 24 hours of harvest.
Here's another major concern people have. After a few days, you might notice this white, powdery substance settling ominously at the bottom of the jar. It kind of looks like dust covering your beautiful aromatics. Seriously, you can completely relax about this. That white sediment is perfectly safe. It's literally just spent lactic acid bacteria and a totally normal yeast byproduct. Far from being a sign of ruin, seeing that white powder actually confirms you've pulled off a highly robust, successful fermentation. Your microscopic army did exactly what it was supposed to do.
And there you have it, the strict science behind the perfect crunch. Decoded. So, armed with the 3.5% saline protocol, knowing how to execute a blossom amputation, deployed tannin armor, and hold a strict anaerobic lock, the real question is, are you ready to conquer the enemies of crunch and start your own organic fermentation lab?